Good morning. We are solving sums from miscellaneous exercise. Sum number 6. Just listen to me. You have to write the solution after the lecture. With the usual notation, prove that sine of a minus b upon sine of a plus b is a square minus b square upon c square. By sine rule, what is a upon sine a equal to b upon sine b equal to c upon sine c? It is k. So a is k sine a, b is k sine b, c is k sine c. So RHS is now a square minus b square upon c square. So k square sine square a minus k square sine square b upon k square sine square c. K square gets cancelled. What is a square minus b square? A plus b into a minus b. Next step, apply formula sin a plus sin b and here sin a minus sin b. Now a plus b plus c is pi. So angle C can be replaced by what? Pi minus a plus b. But sine of pi means 180. Sine of 180 minus theta is sine theta only. That is why you can see sine square a plus b in the denominator. Now next step, just see the numerator. I have rearranged the terms so that I can use the formula 2 sine theta cos theta is sine 2 theta. See, I have brought this term here and in exchange I have shifted this term at the end. Okay. So this is of the type 2 sine a cos b, 2 sine a cos a, that is sine 2a. So this becomes sine of a plus b into sine of a minus b. Now denominator is sine square a plus b. One sine of a plus b gets cancelled. What remains is sine of a minus b upon sine of a plus b, which is nothing but right hand side. Now, seventh one, this is an interesting and an important sum from exam point of view. In triangle ABC, prove that a minus b square cos square c by 2 plus a plus b square sin square c by 2 equal to c square. Begin with LHS. Now, what is a minus b square? A square plus b square minus 2ab. What is a plus b square? It is a square plus b square plus twice ab into sin square c by 2. So it is a square plus b square. I have opened the brackets cos square c by 2 minus twice ab cos square c by 2 plus a square plus b square sin square c by 2 plus twice ab sin square c by 2. Take a square plus b square common to get in bracket cos square c by 2 plus sin square c by 2, which is 1. Take minus twice ab common to get in bracket cos square c by 2 minus sin square c by 2. Now what is cos square theta minus sin square theta? Cos 2 theta. So this is cos c. So what we get is a square plus b square minus 2ab cos c, which is nothing but c square. Reason cosine rule. Now this is nothing but right hand side. Sum number 8. In triangle ABC, if cos A equal to sin B minus cos C, then show that it is a right angle triangle. Cos A plus cos C, rather cos A is given to be sin B minus cos C. Rearrange the terms. So cos A plus cos C equal to sin B. What is cos A plus cos C? 2 cos of A plus C by 2, cos of A minus C by 2. Now, a plus b plus c is pi. So what is a plus c by 2? Pi by 2 minus b by 2. So this gives 2 cos of pi by 2 minus b by 2. Cos of a minus c by 2 equal to. What is sine 2 theta? It is 2 sine theta cos theta. You may ask me, sir, but it is not 2 times. It is just b. Remember, any angle is 2 times its half. So sine b is sine of 2 times b by 2. That is why it is 2 sin b by 2 cos b by 2. 2 gets cancelled. Now it is cos of 90 minus theta sin theta. Right? So I can say that sin b by 2 gets cancelled. So what remains is cos of, right, a minus c by 2 is cos of b by 2. Now two angles are, rather two cosine ratios are same. So I can say that angles are same. So a minus c by 2 is what? B by 2. So a minus c is nothing but b. Therefore, angle A is what? It is nothing but B plus C. Now for triangle, A plus B plus C is 180 degrees, pi radian. Replace A by B plus C. Therefore, or I may say replace B plus C by A. That is better. Therefore, A plus A 180 degrees. So what is the measure of angle A? 90 degrees. So in a triangle, one angle is of measure 90 degrees. Therefore, triangle ABC is a right angle triangle, right angled at A. Right. Sum number 9. If sin A upon sin C is sin of A minus B upon sin of B minus C, then show that A square, B square, C square are in AP. Now sin A upon sin C is given to be this, cross multiply. So sin A into sin of B minus C is sin C into sin of A minus B. Now A plus B plus C is pi. So what is A? Pi minus B plus C. See, bar means bracket. So sin of pi minus B plus C into sin of B minus C equal to sin of pi minus A plus B into sin of A minus B. Now sin of 180 minus theta is nothing but sin theta. Therefore, this is sin of B plus C into sin of B minus C equal to sin of A plus B into sin of A minus B. Now multiply both sides by 2. Why? So that I can use de facto formula. 2 sin of B plus C into sin of B minus C. What is 2 sin A sin B? Cos of first angle minus second angle minus cos of first angle plus second angle. So this is rather 2 sin A sin B is cos of A minus B O. Actually, I should have written minus cos 2b, right? 2 sin A sin B is cos of A minus B minus cos of A plus B. So this should have been, I'm sorry, cos 2 sin A sin B is cos of first angle minus second angle. Or I'll do one thing. I'll say that multiply by minus 2. Just make this change so that this is correct. Cos 2b minus cos 2c is cos 2a minus cos 2b. Now, what is cos 2 theta? 1 minus 2 sin square theta. What is cos 2c then? 1 minus 2 sin square c. But minus is there. So it is minus 1 plus 2 sin square c. Rearrange the terms to get sin square c minus sin square b equal to sin square b minus sin square a. By sine rule, sin A upon A equal to sin B upon B equal to sin C upon C equal to K. So what is sin A? AK. What is sin B? BK. What is sin C? CK. And therefore, this becomes C square K square minus B square K square equal to B square K square minus A square K square. I can cancel K square. Therefore, I get C square minus B square equal to B square minus A square. Can I conclude that A square, B square, C square are in AP? Yes, I can. Why? Because here the difference between two consecutive terms is constant. You may also say that C square plus A square is twice B square, right? So B square is C square plus A square upon 2. That is B square is an arithmetic mean between A square C square. Same thing. That shows that the terms are in arithmetic progression. This is an important sum. Sum number 10. You have to write the solution after the lecture. Solve the triangle in which A is root 3 plus 1, B is root 3 minus 1 and angle C is 60 degrees. What do you mean by solving a triangle? See, for any triangle ABC, there are 6 elements. Small ABC, which are the lengths of the sides, and capital ABC, 3 angles of a triangle. Now, out of these 6, 3 will be given and remaining 3 we are supposed to find. So in this case, we are given length A, length of side BC, which is A, length of side AC, which is small b, and angle C. So we have to find small c and remaining 2 angles. We are given A equal to, B equal to, and angle C equal to. By cosine rule, what is C square? A square plus B square minus 2AB cos C. What is important? Substitution and simplification. Cos 60 degrees is half. Simplify to get C square as 6. So what is C? Root 6. So we have obtained the third side of triangle. Now by sine rule, see, this is interesting and important. By sine rule, A upon sine A equal to B upon sine B equal to C upon sine C. Substitute, rearrange the terms. So sine A is root 3 plus 1 upon 2 root 2. And what is sine B? On the rearranging the terms, root 3 minus 1 upon 2 root 2. You may say, can we use log tables? You can, but that won't give you the exact angle. See how terms are rearranged. Consider sine A first. Split numerator. So root 3 upon 2 root 2 plus 1 upon 2 root 2. What is sine B? Root 3 upon 2 root 2 minus 1 upon 2 root 2. That is sine A equal to root 3 upon 2 into 1 by root 2 plus half into 1 by root 2. Same is done for sine B. Now consider sine A. Can I replace this by sine 60 degrees? Yes, I can. What about 1 by root 2? This I can replace by cos 45 degrees plus half can be replaced by cos 60 degrees and 1 by root 2 by sine 45 degrees. So that this is of the type sine alpha cos beta plus cos alpha sine beta. Is that clear? So that gives me sine B as sine 15 degrees. So B equal to 15 degrees. Actually, it is sufficient to find either angle A or angle B. Why? Because one angle C is known. So if we know any two angles of a triangle, third angle can be obtained easily. So there was no need to find sine B or simplify sine B rather. It is sufficient to simplify any one. If you go for sine A, you get sine A as sine 105 degree. So A has to be 105 degree. Then you can argue that C is given to be 60 degree. So the third angle B is 180 degree less 60 degree less 105 degree. That is 15 degrees. That is the answer. So this is the key. This step rather. From this sine 60 cos 40 plus cos 60 sine 40. Sum number 11. In any triangle ABC, prove the following. First part, A sin A minus B sin B is C sin of A minus B. Usually they start with LHS. Here I have tried with RHS. In fact, this is RHS, right? Not LHS. I have tried with RHS first. Okay. Now you can start writing. RHS is what? C sin of A minus B. Now by sine rule, what is C? K sin C. Okay. Because of course you have to say that by sine rule, A upon sine A equal to B upon sine B equal to C upon sine C equal to K. So C can be replaced by K sin C. Now A plus B plus C is pi. I haven't written those reasons. You have to mention them. So what is C? Pi minus A plus B. Sine of 180 minus theta is sine theta. Next step, K upon 2 into 2. Actually, you have to read between the lines. 2 sine of A plus B into sine of A minus B. What is 2 sine A sine B? Cos of first minus second. So cos 2B minus cos of first angle plus second angle. But what is cos 2 theta? 1 minus 2 sine square theta. Is that clear? So rearrange the terms. Now what is cos 2b? 1 minus 2 sine square b. Cos 2a, 1 minus 2 sine square a. 1 gets cancelled, 2 gets cancelled. So what remains is k in bracket sine square a minus sine square b. Open the bracket to get k sine square a minus k sine square b. Now rearrange the terms. So k sine a into sine a minus k sine b into sine b. But k sine a can be replaced by a and k sine b can be replaced by b. Reason sine rule. In the beginning only we have written that small a is k sine a. So k sine a is small a. So what is right hand side? It is a sine a minus b sine b, which is nothing but left hand side. That's it. Second, prove that c minus b cos a upon b minus c cos a is cos b by cos c. Begin with LHS. Obvious method is actually use cosine rule and replace cos a by what? B square plus c square minus a square upon 2bc. Absolutely right. You will get full marks for that. But if I use projection rule, what will happen? C is to be replaced by a cos b plus b cos a and b by a cos c plus c cos a. If I do so, what remains is a cos b upon a cos c. That is cos b upon cos c, which is nothing but right hand side. Fourth one, a simple one. Prove that AC cos B minus BC cos A is A square minus B square. Begin with LHS. Use cosine rule. Here AC gets cancelled. Here BC gets cancelled. LCM is 2. So numerator C square plus A square minus B square minus C square minus B square plus A square. So it is 2A square minus 2B square upon 2. Take 2 common from numerator, cancel that to get a square minus b square, which is nothing but right hand side. Fifth one, again a simple one. Show that cos a upon a plus cos b upon b plus cos c upon c equal to what? A square plus b square plus c square upon twice abc. Simple. Use cosine rule. Of course, you have to mention the reason here. So use cosine rule on cos A, cos B and cos C. Now what is LCM? Twice ABC. So what is numerator? Numerator is nothing but A square plus B square plus C square. So what we get is A square plus B square plus C square upon 2ABC, which is nothing but right hand side. So that's it for today.